Frequency counter kit build and test.
Hi guys, welcome back to the channel. It's Paul, Mike 0, Whiskey November uniform, 426 Charlie Tango 730. If you catch me on 11 metres and PMR 446. Now we see a circuit board in the helping hands today. This is the little frequency counter kit that I picked up from the Blackpool Rally. Came with all the parts to build it, but it didn't come with a set of instructions. But if you look at the board, I'm not sure I can zoom in right now, but if you were to look at this board, all the positions are marked as to what goes where. So 3, 4, 1, 4, 8 diodes just over here, 10k resistor there, a load of 1k resistors there, a microcontroller. It's a PIC16 F628 apparently. The microcontroller's down there on the bench with the legs facing up. A couple more resistors there, a DC jack, and transistor type components. They probably are actually transistors. I think that's a button. I haven't seen a button in the pack. Oh yes, there is a button in the packaging. Never mind. Another 4148. A crystal, which it suggests is 20 megs. Yeah. And I'm guessing that's the signal in. It's DC 5 to 9 volt rated, so it'll run off a PP3 battery if I wanted to do that. So I'm going to try and assemble this on camera. This could be fun. So check it's all still in shot, because knowing me I might wander off shot. So soldering iron is up to temperature. I haven't wet the spunder on it yet. I really should do that. So, and we'll be using today lead-based solder. No lead-free solder, not anymore. I refuse to use it if I can get away with it. But if I have to use it, I'll have to use it. So I'll pause the video and then we'll come back to that. Rightio, so let's start building this thing. So it came with a bag of components. I've already taken the microcontroller and the IC socket and the displays out of the packaging. So let's start with, well, let's just tip everything out so I can see where it all is. Let's put it over there and see what we got. We've got plenty of resistors, some diodes, there's 4 diodes, and there seems to be 4 diode positions on the, there's a transistor type package there. It's a bit tangled up. There's a couple more loose resistors there. 1, 2, 3, 4, 5, 6, 7, 8. 8 of these ones. 8. By the looks of it. 1, 2, 3, 4, 5, 6. Actually, there's 9 of these. And those are the resistors. Now, what I try and like to do, start with the smallest components first, which are these ceramic capacitors. I'm going to need a magnifying glass to see the markings on so I know where they go, which is why I've got this magnifying glass here. Not a very good magnifying glass. It says 22 on it, which means it's the 22 picofarad capacitor and it would go in that position there. I'm going to put the capacitors in first because they seem to be the smallest components. The resistors are slightly bigger. It goes in there. There's another 22 picofarad capacitor. There's 2 more actually. 22. Okay. So these are the smallest components and the holes are most likely to block up. Oh, this one, I can't even read the markings on that. Ah, it says 22. Good enough. Should be 3 22 picofarad capacitors by the looks of it. That one gone in. Kind of has. And should be a 102 as well. There's another 22 picofarad, so either they've given me a spare one or there's another position for that, which I can't really see right now. Now, they might have given me a spare 22 picofarad capacitor, unless I put 22 picofarad capacitor in the wrong place. Check that one, I've just can't read. This one I can definitely read, it's 22 picofarad. So I'll put that one in there. I can definitely read that. Okay. can't see another capacitor position that would take a 22 picofarad capacitor. So let's go on to the next one. 102. So that goes in the position labelled 102. There you go. So I know where they all go now. It's just a case of whether they'll actually stay in when I try and solder them in. Depends on the pads on this as well. There should be a 104 as well. So that's the 104. So I'm not 100% sure what that's going on with that spare 22 picofarad capacitor. Can't see a position for it. So those are the smallest components. They're probably all going to drop out as soon as I flip this thing over. So there is the fun part. Let's see. I've got to try and adjust it so I can get to the underside of the board without breaking the board. Take the board out. What some people do, just to try and stop these from dropping out, is slightly splay out the legs, but that makes disassembly a wee bit harder. Which is why I don't personally like to do it that often. It does sort of stop them from coming out. You know what? Let's see, will any of these stay in or will they all drop out? They're staying in. So that's a good start. Okay, so I've got a multimeter here because I'll probably need that to test all the resistors to figure out which ones are which. Because they're those horrible blue coloured ones that I don't particularly like and I can't read very well. Let's just give this iron a bit of a good old clean up properly just to take any of the muck off it. Because I'd much rather use a... Right, there we go. Oh. These pads don't look particularly big, but we'll give it a go. So you don't carry solder, you always feed it in. Oh, my hand was shaking there, that's unusual. Oh, no, I'm not sure why my hand was shaking there. Doesn't usually happen. There we go, much better. Let's do one side of each of these first. Let's try not to shake. Okay. That'll give me some room to straighten them out if that needs to be done. Now there is a crystal in this kit, like I said, and I don't really want to be applying heat to that for too long because it could break it and then the thing probably won't work. I'll have to buy a new crystal, which won't be cheap. I'm just trying to think of how I can do that when I come to it. Yeah, wasn't meant to solder both sides of that, and I put a bit too much solder on that side. Never mind, it's in now. Oops. Yeah, a bit too much solder there, I think. Probably a bit too much solder there as well, but that's okay. Not going to cause it to malfunction too much. So I've just got to do these three in here, which I've not actually done yet. So, yeah, remember when you're soldering, you don't carry the solder over, you feed the solder into the joint. Well, that's the general idea anyway. Doesn't always work that way though. These are quite small pads. There's quite a lot of flux in this solder as well, which is actually very helpful. And this is making better joins than... Oh, maybe not. Helping hands are starting to move. I think this is doing a better job than the lead-free stuff that I've got. So this won't be compliant with the reduction of hazardous substances regulations, but who cares about that? Because it's not a commercial product that I'll be selling, it's just a kit that I've bought So, right, that appears to be all the capacitors in, unless I've missed one, which is why I've got an extra one. So, let's have a look. Board coming back out, and yeah, the capacitors are all in. I don't like the way, I see, it's one of those types of boards, some of the solder's actually gone through. That's alright then. Let's start snipping them back. So, I need my snips, which I've actually put here. These are my new snips from the Blackpool Rally. Just start cutting these leads off. Doing that off camera probably. Yeah, it's one of these boards with plated through holes, so that's the capacitors in. Some are flush with the board, some aren't. So I had a problem with a Pixie kit that I built a while ago. I'm going to build another one of those on the channel, but haven't got one in yet. So, next component. Just looking at this, so the next components would be, which would be the best components to start with? So, there's a whole bank of 1K resistors that could go in. But I'm thinking on putting the transistors in, because there's looks like there's 2 of those to put in. Now, got to get them the right way round, obviously. I'm going to do them one at a time. This is where I'm going to need the magnifying glass again. Make the numbers on these quite minuscule. Can't read that. That's annoying. Can't read that one. Well, it's... Ooh, I can't read that one. There's a 9014 and a 9018. I know that much. This has got a light in it as well. It does help, but no. This is the curse of having dodgy eyesight as well. I cannot read that. Let's have a look at the other one. Can't even read the print on that. So I have no idea which transistor is which. And that one's labelled... Okay, that one's labelled 7550A1. The other one is labelled... You can see it. Can't tell what the other one's labelled. I really cannot see that. Yeah, I'm going to pause while I try and look what that is. Okay, so the one I couldn't read the screen print, or whatever the hell type of print, I think it's laser etch, is actually the 9018, which goes over there next to a 1K resistor and a 100K resistor. So, let's get it popped in. There we go. Now these are heat sensitive, so you don't want to be lingering too long with them. That's the usual thing with transistors, they don't like being heated up for too long. They don't like getting hot, which is why power transistors usually are fitted to heat things. So let's see. Now, I could have tested to find out what that transistor was in this meter, but they wouldn't have really told me much because I don't have a data sheet for anything. Okay, there's another transistor with the kit, which I can't read the number on at the moment, but we'll come back to that. So there's 3 transistors, but I can only see positions for 2 at the present. So there might be a 3rd position that I've just not seen. So we'll see. This iron needs to be a bit cleaner, I think. go. Let's do this carefully one at a time. Okay. Should do the centre pin first, but I've started, so I'll finish. To make sure it's not shorted out there. If it is, I'll clear the short later. A lot of flux though. Let's have a look. So I'll check that's not shorted together. If it is, I can fix it though. So I've got a multimeter here. This is the DT9205A multimeter. I don't know much more about it than that. Okay. Checking there, not okay. Okay, not helpful. Joints on that don't look as shiny as I'd like, so they look a bit dry. I think that's fixed it. Yeah, because dry joints fail over time. Let's have a look. Look with my magnifying glass, that'll help. They look alright. Don't look as though they're shorted together. But it's in the right position, so snip snip. I don't like soldering transistors if I can avoid it. Just like I don't like soldering a lot of integrated circuits. Some of the solder's flowed through. So it's one of those types of kits that I don't particularly like very much, where it's plated through holes, both sides. But I suppose it would work. Hang on. The 7550 there, and the 9104 goes there. So I'm guessing that this, the one that is a 9014. So I put 9014 into there. I'll check I put the right transistor in there. So that's the 9014. That's the one that goes over there. Just check that I put the right transistor in the right place. So it'd be a bit daft if I haven't. This one. Yeah, looks like I might be okay. This one's a 7550 transistor, which goes over there. So just play the leads out again. So that goes there. Try not to wander off shot too much. So let's put that back into the helping hand. I'll start by soldering the middle pin first and then the two outers. Again, I don't want to linger too long with the iron. Okay. Not the best at soldering, but it's not something I'm incapable of. I think I might have put too much on the middle one, but that's fine. Can be fixed later if it needs to be. I do have a solder sucker for that purpose. Right. Let's just check it's not shorted. I'll pull that off. I don't need that croc clip on there. Just check there's no shorts between the pins. Suggests it might be shorted there. So I need the solder socket. So it might be too much on the middle. then it could quite easily be just the way the components are routed. Okay. It could just be, yeah. Just thought, worth a check. And check the other side of the board as well, so it's sometimes worth a check. Okay, so it's in. I don't see anything that side shorting, so it's probably just the way the circuit's routed. So it should be fine. So let's just start snipping them off. Oh, that didn't take long. Right, one final transistor to put in, which is this one, which goes over there. It says 9014. The diagrams on the board suggest which way the case has to go. Doesn't usually mean anything though. And these Chinese kits, because this is actually a Chinese kit. Sure it's not twisted. Too much stress on the case. Now I'm not looking forward to soldering the crystal in because my luck with crystals ain't that great. So I'll do the same again. Middle with this one, middle pin first. Sure everything's okay. Ooh, I'm shaking there, that's not great. Yeah, got a solder bridge right there, look. I'm hoping not to get. So, not a problem because I can clear that out. My desoldering tool will work. This is a solder sucker, by the way. I'm not sure if you can see that. You press the button, put it over the solder joint, melt the solder, press this button, it sucks it all up. Well, that's the theory. In practice, it doesn't always work that way. This one I've had for years and has had to be repaired on that many occasions. It's unreal. It's time for a new one, I think. So I do have a solder bridge there on that transistor, which I don't want. That's undesirable. Solder bridges are always undesirable except in option jumper settings where you have to set it using a solder bridge. Now I can't get that out, so that's most annoying. It's because the hole in there is blocked. So let's see if I can just push the pin through. I might not be able to remove the spring because the end that's in is kind of... Oh my word, this is well and truly jammed. I'm going to use one of my multimeter probes. On the cheapy multimeter to see if I can clear some of that out. Because it is a cheap multimeter, it's not my expensive Unity UT58C, which is in here somewhere. But this was the meter I had to hand, so... And it does work. It does just as well as my more expensive, and getting on a bit now, Unity. So, let's see if we can get rid of that solder bridge, shall we? Can't really, I'm not sure if you can see it, but I know I can. So I need to heat the solder. Job done. Spot on. Might get a short reading because transistors are like little switches. They either pull to positive or negative to switch. That's okay. Right. So, next job, now put the transistors in, at last. I'm going to swap it back over and we'll start, I think. We'll go on to the resistors. We'll start with the 1Ks. So I'm going to figure out which ones are the 1Ks. So if I set my meter here to 2K, will give me an idea of which one of these resistors. Ooh, let's give me some weird readings. So I've got the multimeter. It's not in shot, I don't think. It's saying 982. That's good enough. A bit of tolerance. These look like these are the 1Ks because there's more of them than any other So these look like they're the 1Ks, so let's stick them all in. Now, I'm going to have to... It doesn't matter which way round these go in, then they're non-polarised. So, I can put them in either way. That's the thing with resistors, they're non-polarised, so they can go in either way. Diodes are polarised, so they have to go in one way. They have to go in whichever way the band points, usually. And transistors generally have to go in whichever way, with reference to base emitter, collector, or source gate and drain, depending on whether it's a normal NPN, PNP, or MOSFET. So those are the ones you'd find. LEDs are the same as diodes, they go in only one way. If they're going backwards, then they don't work. So I'm hoping this works when it's finished. If I can find a 9-volt supply to run it off. Like I said, it'll run off a PP3 battery. Well, that's the idea. One hopes. Just checking this is still recording. It appears to be. Because I am recording this in 4K and that will use up the space quite quickly, which is not ideal. Key dear key. This one doesn't want it. There we go. Guessing these 1K resistors are for the LED display. I'm not sure. So I'm not actually sure how it's running the LED displays, which we'll come to later on. It's a frequency counter that I believe goes up to 50 megahertz, and they do have equipment that will generate RF on those frequencies. Definitely. He says, looking at the 991A tucked over in the other side of the room now. There's one more of these resistors. But there's actually 2 left on my thing, so we'll keep the remaining one on the piece of paper, because that goes in a different position on the board. So that's all the 1Ks. All the 1Ks in place. Okay, so I'll take this back out the helping hand so I can get to the underside of the board. This is where maybe taping these on would have been a good idea, but I'm sure that it'll all be okay. I'm no expert at building kits, so you know, just try not to wander off shot. It's quite difficult to do. I can sort of see where the camera is, but it's still quite difficult to make sure I'm not wandering off shot. Now, because this is my kit and I don't mind, it was only a few quid as well, actually, this. Got it from Canny Components at the Blackpool Rally. Part of my haul, I did show my haul at the end of that video, where I showed what I'd bought. So this is actually going to be pretty good if you decide you're going to use a CB radio on 10 meters, because it will show the frequency where you expect it to be. I don't have any tape at the bench at the moment, so I can't tape those down, but it shouldn't be a major issue as long as they stay put. I mean, I'm not bothered if they're crooked or not, because I'm not OCD or anything. So let's start soldering in these 1K resistors. I'll start from, he says, thinking about it, the right, as I'm looking at it. I'll try again. Ooh, too much. Too much. Not enough. too much. Yeah, that's better. If you can hear the wind, then it is actually windy outside right now, which is why I've not got any aerials up and not doing any radio stuff. Try that again, because that is definitely not enough. There we go. Try again. Yeah. Try not to keep the soldering iron on the board too long, because otherwise lift the tracks and that's bad news, usually. Yeah, I've just put more solder onto the one next to it, that's annoying. And I've got a solder bridge. I'll fix that in a minute. Right. First thing I need to do is try and fix that solder bridge that's appeared. Remember, this is me attempting to make this kit up with no instructions at all. It's not great that it's a kit with absolutely no instructions. Oh, that's not great. Bits of solder just flung out the solder sucker, that's a bit annoying. But those all look as though they're in. They're probably not completely level underneath, but that's not a problem. I can kind of fix that. Yeah, definitely. There's one here that's not quite straight. I'm not 100% bothered by that. Just it would look neater. Get it? Ow. There's another one there, look. There we go. They're not 100% straight, but they don't have to be as long as they're making an electrical connection. I mean, if it was a commercial product, then it would all be done by machine anyway these days, because it's all surface mount components, not through hole like this. Just keeping an eye on my microphone battery levels, because it is a wireless microphone I'm using. And also my SD card, which is now 4 gigabytes. I don't think there's much left to record. So, solder the other side of these resistors in. Make sure my soldering iron's in a good shape for that. Now, because I'm going to take a break as well while I clear the SD card for the next part of the video. Because I'm going to have to. Oh, I managed to solder 2 at once. That's a first. That's why I want to pull the small components in first in case I accidentally clog the holes with solder. If I'd taped them down, it would have been flush, but because it's not a commercial product, it's just a kit, then it's not too much of an issue. So I'm at 3.9 gigabytes because I'm recording in 4K. It is actually running it down a bit quicker than one would like. So what I'm going to do, I'm going to snip all these leads off, snip them flush, make them look tidy, with my nice new pair of snips. Just got a bit stuck to it. I need to degauss these, but I don't have a degaussing machine. No, I didn't snip this transistor off either, so there we go. There we go. So, got 3 transistors, 4 capacitors, actually 1, 2, 3, 4, 5 capacitors. So this is how far I've got so far. I've got to stick in another 1K resistor, a 100K resistor, a couple of 10K resistors, 1N4148 diodes, power jack, a button, crystal. Yeah, so that's where I need to get to. But the camera is starting to run out of space rapidly because, got to remember, I am recording in 4K and that uses a lot of space. So I'm going to take a break, which will allow me to take the SD card out of this and transfer what I've done to the video editing suite. So I'll catch you in a little while after I've had a cup of coffee and done that. Okay, so I've now had my cup of coffee and we're back. I'm going to move this a bit further over this way actually, because I don't think it's quite in shot because I had to take the camera off, but it's there now. We're good. So, when I stopped, I got all the resistors in, got all the transistors in, and I got all the capacitors in. So, well, nearly all the resistors. There's still a couple of resistors to go. There's a 10k there, there's a 100k there, and there's a 1k there. So, those should be the next ones I do. So, obviously I've got one 1k left. I can confirm that's a 1k, although my meter's decided to turn itself off. To turn it back on, I have to reset it. So my final 1k should be the one in the paper. I'm not sure you can see it. There we go. So that's the 1k. It's just remembering where the camera is. And that's a nice easy one to check out. I just stick it across this multimeter down here. So this is the last 1k resistor, which I'm going to put in here. Then there's a 100k resistor I need to find as well. So I'm going to put the 1k resistor in first. Let's bend those back a little. Bend them back in a way which means it's going to be impossible to get it out if I decide I need to change that. But I shouldn't need to change that. So resistors don't generally fail unless the rating's been massively exceeded. Which is quite fun on some sorts of resistors, but quite dull on others. I have managed to, well, maybe not blow one up before. Ooh, the helping hands is actually moving, which is not helpful. It's supposed to be helping hands, not let's just move everywhere and not do the job as we want. Right, so that's in. Check on the other side, make sure it's straight. Yeah, good enough. That's good enough for me. Give it soldering iron a clean. I recommend lead solder if you can get it. I don't recommend the lead-free solder at all. It's just not ideal. That's why a lot of modern electronics fails, because of the lead-free solder. Because they decided lead was poisonous and would leach into the environment. Well, granted lead is poisonous, but to be honest, it's not going to be that much of an issue in the grand scheme of things. So I don't think much lead has leached out, but I think there's far more nastier stuff in lead-free solder than there is in the lead solder. So I'm just going to cut those leads off. Just chuck them down there. Now I need to find the 100k resistor. I think it was 100k. Let's check the board. Flip it back over. This can be mounted in an enclosure. So, yes, it's a 100k resistor I'm looking for. This is where I have to test these resistors because I can't read the bands on these blue ones. Okay, so that's 95 according to that. This is on the 200k setting, that's come up as 95. So I think there is some tolerance there. So I'll check the other one. So that's the one I suspect to be the 100k. It's reading 95k. That's reading 9k, so that's a 10k resistor. So that's this other one. Yeah, it's reading about 9k, so that's a 10k resistor as well. So let's double check this one. Yeah, it's 100k with a fair bit of tolerance, so that's fine. That's the 100k because it's going up as 90 some k on my tester. Oh, that's dropped straight. That's actually dropped a bit. Yeah, that's close enough to 100k, so that's the 100k. The two remaining resistors are 10k. The wind is still really howling out there. Yeah. Oh well, what can you do? So that's the resistor now in. This will be the last resistor on that side of the board, so I'll just bend the leads back a little just to stop it dropping out. I know I shouldn't really do that. It's not something I like to do personally, but, you know, has to be done. So, let's get the Juicy lead-based solder out. I got this from Canny Components as well. And note that I can get more off them if necessary, because they actually do have a little outlet as well where I could possibly go and get stuff. This is the Duratool branded stuff, which I can't remember who sells that brand. I think it's Farnell's, if I'm not too much mistaken. So, that's now in. I'll snip the leads on that with the snips. These are also from Canny Components. I do have some blue handle snips somewhere, but I've misplaced them, so these will do. The lead stuck to the board there. Right, so that's all of those resistors in. So let's see, what resistors remain? There's a 10k resistor and another 10k resistor. Those are all next to the diode, so that's these two here. So these two are the last resistors I have in the package, so we'll get them put in. Okay, so that's one in. I'll solder that. Tiny little bit of solder stuck to one of the IC socket pads. I'll show you how I'm going to put that IC socket in later, because I do have a way I normally like to do that. Put my solder sucker out of the way, so I don't need that right now. Okay, so get my solder. £1.50 for that tube of solder. £1.50 well spent. Well, £3 well spent on solder, because I've got another one of those. Oops, shaking again. Happens. There we go. It's in. Soldering isn't exactly a difficult thing to do. Anyone can learn how to do it. I've snipped all the leads back. I know some people might be a bit put off with the fact that you've got to work with a soldering iron which can reach up to, in my case, 350 degrees Celsius, but don't be put off by that. It's not too much of a bad thing. So that's all the resistors in. Actually, no, there's still one resistor. Getting ahead of myself there. So I'll put this the right way around. So this one goes next to the other three 1N4148s, which are those. I believe they're 1N4148. And on the board it shows how those go in as well, which is actually very, very helpful. Buying a little kit from eBay and having a go at soldering is a good way to learn actually how to solder. Not one of these kits though, because this one might be a little bit more advanced. You can get little kits off eBay or anywhere that sells electronics, but especially eBay, because you can get cheap kits from China. This is a Chinese kit, but which is why it didn't come with any instructions, which is why I've got to use a bit of guesswork. So I've just got to find out where I put that resistor now. There it is. I have to give my iron a bit of a clean again, I think. Ah, I love the... it's all going towards the camera now. Cool. I do like that. That whiff of smoke as the flux boils off. Whoop. It's tried to escape, but brilliant. Did use it more solder on that one. Waft it out of the way. Maybe you didn't see that. So that's now in. That's that resistor there, now soldered in. Bring it back in. There you go. And let's snip the leads. I'm just trying not to burn myself on the glue gun, because I've had to break out the glue gun to fix one of my other little tripods. Because I've got two identical tripods that I use for putting around here. One was used for another project, but that project's not in progress at the moment. So I had the tripod spare because the other one's broke. It's just a cheapy one, it's not the Gorilla Pod. So, helping hands have fallen over. Just try not to crush the IC, that would be bad. So, probably won't be able to replace that readily. There we go. So, we've got all the resistors in, all the capacitors in, all the transistors in. Now going to move on to the diodes. There's 4 diodes. Then they're all 1N4148 diodes, which is, there they are on the camera, these. Not sure if you can see them. So they've all got a black band on them, and I'll bring the circuit board in so you can see this. Where the diodes go, you can see there's a white band there, that's where the black band should be going. It's the way they face. There's a switch, trimmer, spare capacitor. So, diodes are a polarized component. The black band indicates the negative. And these are these glass-bodied ones, which I'm not the biggest fan of, but, you know. See if I can get them in. Okay, so there's 3 of these in here, and 1 next to the push button. So I'm just going to stick them in. Yeah. Yep, so diodes have 2 terminals on them, one called anode, one called cathode. Anode is positive, cathode is negative. So if you ever come across that when you're learning how to build kits and how to solder, then you know which way around these go. So I'm going to leave the remaining diode in the bandolier until I actually need it. As I say, you can buy kits from eBay pretty cheap, or what you can also do if you want is you can buy what's called a Vero board from an electronic supplier. You can look for component schematics online if you're able to read them, build a kit that way, but that's more for if you're used to actually building circuits. I recommend buying a kit to learn how to solder first before you go down that route. I've been soldering since I was at school, which was quite a long time ago now, which is why I'm a bit of a dab hand at it. I used to do it at college as well, in the halls of residence. Used to take stuff to bits, which obviously had lead solder in it, because while I was at college, the lead-free solder wasn't actually a thing. It only became a thing after I left college. Most annoying, so I'm going to do the top ones first. Ooh. Try and do that without shaking. Ooh, there we go. I think I've got the shakes today. I think it's because of all the coffee I've been drinking. There we go. Whoop. It's trying to escape. I'm just hoping that didn't just break the board. I'm quite annoyed. There we go. Let's check how level they are on the other side. They are a bit squint, but that's squint on the bit that I've not actually soldered, which is impressive. Not sure how that happened. So, let's put... I'm going to make it a bit easier for myself. I'm going to solder that middle diode first. Because... Ooh. Much easier. There we go. So I'll just check there's no shorts between those diodes, because that wouldn't really be good. Okay. Yeah. Okay. I think they're all. I think that's just they're all on a common positive. And I think up there. Yeah, they look like they're on a common positive. So that's probably why that was doing that. So just get these leads cropped. Flinging component leads everywhere. Woo! That one was really shot off. Right, so they're now in. So 3 of the 4 4148 diodes are in. 1 more of them, which I've left on the bandolier. Which is now going in. Bring the board back in. I'm sure you would have seen it before I did, but I've seen it here. Okay. Oh, maybe if I don't bend the lead there. I'm going to try and bend them close to the actual component housing, but not right on it. As long as these leads don't snap off, I'm alright, because if they do, then I'll have to order a 4148 diode. I'll check where the black band is on that. It's there. Okay. Check it's still got the band matching the picture on the board. It has. So that's now in the hole, or holes rather. This board is a bit of a nuisance to work with because obviously it's got plated through holes. It's basically taking solder through to the other side, which means desoldering is going to be quite a difficult job if I actually have to do any desoldering. So this is the final diode. Furthermore, there's no more of them. Tiny dot of solder on that. Feed that in. Lovely. Oh, no, lovely. Did shake a bit there. I'm shaking a lot, but I think it might be because I've had too much coffee today. I've just had a cup of coffee, as you know, because I went off to have a coffee break. Bink. Bink. There we go. So that's snipped off, and that's the progress so far. I'm just checking the space on the SD card. We're still good. Right, so next I'm going to fit this crystal. I'm going to find it. And this crystal is 20.000. So I'll put it that way in. This is a bit I'm not looking forward to soldering because, well, the crystal, isn't it? And crystals don't like getting hot. So the crystal is in. This is the bit I'm really not looking forward to soldering because it is a crystal at the end of the day and crystals don't like getting hot. But it can be done as long as I'm quick and as long as I'm careful. Bend the legs back a bit just so it would be better if there was a socket for this crystal, but there isn't. So I'm going to be very steady away with this crystal. I'm going to apply as little heat as possible. Because obviously I don't want to break the crystal because the crystal's necessary. I think it's a crystal oscillator. Ooh, this is when I'm going to have fun. Right, one leg soldered. Let's give that a couple of minutes just to cool the component down. Because soldering crystals is not something I like to do, and if you leave the heat on too long you probably would damage them. And I'd have to get a new crystal, and crystals aren't cheap. So that's why I'm not the biggest fan of crystal controlled sets from back in the day when you have to repair them. Like my realistic scanner over there needs repair because it doesn't work very well. Some of the crystals don't work, I don't think, and I think there's some dry joints, but now I've got some lead solder, I can probably go over that and fix it. But that's a project for another day. I went a bit too much solder there, but that should be okay. I'll take some of that off actually, because I think that is a bit too much. Oh, try again. That's better. Right, crystal is in. It's slightly stood off the board, it's not flush with it, which is fine. Okay, so next, tuning capacitor. As far as I can tell, there isn't a specific way it goes in, but this It's a little trimmer capacitor. I'm not sure the rating of it actually. That fits in that hole there. And this is where I will probably need to tape it. And I actually do have some tape on the bench. I just did not spot when I was looking. Yeah, because I thought I didn't have any tape, but, you know. Bit of abuse of snips, but this is the only way this is going to be held in. Because otherwise that's just going to drop straight back out of the holes, which it has done. So it's a trimmer capacitor for fine-tuning that. It's one thing crystals do, is they drop with age. So when that crystal starts to get a bit older, it'll start to drop in frequency and might not read the correct frequency. So what I can do, I can take that across there and across there. Should hopefully hold it. And I'll solder one of the leads off the component. I really can't believe I said I didn't have any tape on this bench, and then it turns out I did. You know. So let's get that tuning capacitor in on one side, which will be up there. So let's set fire to the tape. Right. Now take the tape off. I don't want to set fire to the tape. Should be fire retardant anyway. Okay, so that's in, it's flush. I need a screwdriver or something to adjust that because I don't have any proper trimming tools. But that's just for adjusting the crystal when it starts to drop. Okay, so that's now in. The crystal is sticking out a bit, which I'm happy with. I'm not going to adjust that. So next is this switch. Doesn't specify which way that switch which way round this switch has to go, but I'm going to hazard a guess. Yeah, because it doesn't actually say which way around the switch needs to go, but that's okay. So the switch is now in. I'm going to do this like so. So I'm going to get my soldering iron. I'm going to make sure it's in shot still. I'm going to get my solder, find the component, wet my soldering iron a bit because it's a bit, and diagonally solder it. And just no stress on that side. No stress on that side. Yeah. So that's now soldered in. So now I've got the switch on the circuit. Now, okay. So next is the IC socket. There's a little cutout in the IC socket. I don't know if you can actually see that. It's just where my finger is there. And that, I'm just checking my video space. We're at 7 GB left, so that's okay. Let's pop that in there. Because I haven't cleared the SD card fully, I've only taken off the files from the last. This will need holding down with the tape again. So, get some fresh tape. And we'll cut it there. Okay, got some string attached, so that's a bit annoying. So what I'm going to do with this, I'm going to put it into the helping hands, and now the IC socket is in the board, and I'm going to start by diagonally soldering pad on opposing corners. So this one, for example, then this one. Try that again. Yep. Okay. So I can take the tape off now, and that should be held in place. All being well. Feels a bit wobbly, so could be... It's in now, it's being held. So it's not too much of an issue. So start soldering it in. Whew. Now this is for the microcontroller, which is supplied with this kit. I think I might have created a solder bridge there, I don't know, but I will check it later. Oops, trying to put it on the right pad now. I really shouldn't drink so much coffee. Ah yes, I've bridged that, so I'll clear that up later. Bridged another one. I managed to clear the bridge though. Well, Christ. Really, I'm shaky today. I want to get that checked. Because I'm not usually that shaky when I solder. Oh, I managed to clear the bridge as well, by the looks of it. That's better. And the shaking comes back. Whew! Right, I'm going to have to get that over the solder sucker. Okay. That looks like it's got too much solder on it, so... There, cleared. Right. IC socket now soldered in after I was shaking about a lot, which is a bit concerning, but I should be okay. Right. The IC doesn't need to go in yet. That's going to happen later on. So, right, so this is the little power jack that it's come with. I'm not sure if I've got a 9-volt supply that will connect to that. I might do though. So I can put that across there. That will also need to be held down with the tape. I mean, I was going to put a PP3 battery snap across it, but I don't have one of them to hand at the moment. This has got some sort of sticky resiny stuff on it, which could be the 2-part resin, I don't know, because I did have a leak of that at one point. I don't know. Okay, so this will need to be taped down. So where's that piece of tape I was using before? Because I think that should still be okay for this. So if I put that across like that, it should hold that in place. So I'll bring my helping hands back. Really not sure why I've been shaking today, but it could be the fact I might have had too much coffee. It does happen. But I'll keep an eye on that, and if it happens more, then obviously I'll go and get medical assistance. So, or maybe it's just the fact I'm a bit nervous because I've not actually done a kit in a while. Oh, that's just pushed through. It's not great. Okay, it's now in place. More on that. There we go. Power jack is in place. Okay. That just leaves the display, which is these. These are actually individual 7-segment displays. Now, these come with this plastic on them, and if you're a regular to BigClive.com, he just pulls those off. So that's what I'm going to do as well. I'm just going to pull off the little plastic and then put them in. And because it's a frequency counter, the decimal points will be facing down. This one's got a slightly bent lead, which is a bit concerning. Let's see if we can get that in there. And this one won't go in because I think it's because of the lead on that side there being a bit out of shape. So I'm going to hazard a guess that this is how they'd go in. Just check all the leads again. Yeah, that's still... Yeah. Try not to break the lead off, because otherwise I'd have to buy a new 7-second display. And not knowing exactly what the type of these is, then that's not really helpful, is it? There we go. We are in. So I'm going to do these one at a time, because I'm going to have to hold them in with the tape. So this is going to take a bit of time. I'm going to check my get my helping hands to stand up, right? That would be helpful because they keep falling over, but I think that's because the magnifying glass is pulling them down. There we go. Just check how I am for storage space. 4.6 gigabytes. We're still good, because otherwise I'll end up in that situation where the video will cut off before we get to the completion, which we don't want. So I'm going to do this diagonal opposing corners again. So I hope I'm not going to shake this time. No, not this time. Okay, that's going to hold that in. Allows me to take the tape off. So let's see if I can get the 7-segment displays in. So it's going to be fun because there's not a lot of space here. Need a thinner soldering iron, I think. This one might be a bit too big for this job. I'm shaking again, which is very annoying. Just try not to flood the hole immediately next to it with solder, because that's not going to end well, is it? Yeah, that's my problem. See if I can clean that up. There we go. Got it. Should be fine. Yeah, I've just bridged that. Not ideal. And that. And that. It's alright. So wherever I've bridged it, I should be able to fix it. That's still bridged, so there we go. It just wicked up into the iron, that's fine. So don't want solder bridges? Absolutely not. Ah yeah, still in shot. I was a bit worried it had wandered off shot there. So that's one of the 7-segment displays in. So let's do the same with the next one. Pop it in. That one went in a bit easier, that one. Actually, that one's in upside down, that's not helpful. So I'm pretty sure that the decimal points have to be at the bottom, because it is a frequency counter. There we go. And let's do a big Clive. And pull the plastic off the top of the display. There we go. So that's the second one now sat in the board. It's not... Well, it's actually staying in place, that one, so... So same thing again. I'm going to just solder 2 diagonally opposing corners. I'm just going to check my storage with 3.6, so... Because this is in 4K, it's quite a long video. I may have to go and... that didn't work, did it? That did though. There we go. So I've soldered that diagonally opposing. So all I've got to do now is just solder the other pins, which is the fun part. Okay. 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 No, maybe not, because this one hasn't gone. There we go. Yeah. Solder bridge again. Ugh. Try that again. There we go. Fixed it. That's just bridged. Okay. No problem, I can fix it. Now that's all bridged together, which is a bit annoying. That is fixable. There. Okay. Remember, I'm not an expert at building kits. So, those are all in. I'm just doing another check and we're about to hit the 1 GB mark. So I'm going to stop the video and we'll continue on once I've cleared some space. Right, so I've got some space cleared off. We're now back to about 15 gigs because it's 4K, it uses a lot of space. So before I stopped, I was in the process of fitting the 7-segment displays, which have been stuck in polystyrene, which I'm not exactly approving of for various reasons. So I'll put the next one in, preferably in the correct holes. Oh, okay, is this another one with a bent pin? Yes. Yep, there's a bent pin somewhere. Just bring it back into shot. Okay, seems okay on that side. There we go, it's in. Then I'll do the big Clive thing. Pull the plastic off. He says, not really getting the plastic off. Whoop! Managed to pull the plastic off, but pull the display back out of the board. It's a bit annoying. Put it back in. Because I'm putting them all in with the decimal points facing down, because I'm pretty sure that's how they're supposed to go in. There we go. And that's now in position. Let's put it into the helping hand, which is kind of sunk that way. I think it might be the weight of the magnifying glass, I don't actually know. Okay, soldering iron still up to temperature. Don't go too close to the polystyrene with the soldering iron, that's never going to end well. And let's see what I can do here. Hopefully my shakiness has stopped. Don't believe it has though. So I'm going to do what I did before. Supposed to heat the lead and then feed the solder in. Do it diagonally opposing first. Like that. Well, it would help to go onto the bloody pad. There we go. And then let's start soldering them in. This will be something interesting to tell my work colleagues when I go in at 5 o'clock. What have I been doing today? Well, building a kit. Well, that and dealing with the chemist as well, but that's for another day because I'm on medication I have to take all the time and they didn't have some of it in the last couple of days, but they've managed to sort that out, so I can keep going. I think there's a bit too much solder on that one there. See if I can rectify that. Excellent. Yeah, that sorted it. Another one there with a bit too much on as well, I think. There we go. And one there. Just bothering me slightly. There's too much solder on some of these. There we go. Fixed. Next. So I've got 2 more of those to put in. So again, there's the display. Let's do a Big Clive to it. You will have seen on Big Clive's channel, if you are subscribed to it, that he does pull that plastic off, even on products that have already been built. Because all that plastic's there for is to stop the resin that they fill these up with oozing out. I'll show you that in the next one I put in. This one's not quite level on the board, there's something underneath it. No, I'm not sure what's going on with that one. There we go, it's level now. I'll show you with the last one before I put it in how the construction of them. So I'll just get this back into the helping hand. That's it. Right. Bit of solder splash there. So these have got 5 pins either side, so I think I have an idea how these might be being run. Okay, let's check it. Yep. Oh, there's my shakiness. Maybe you shouldn't buy me a coffee. Or you could buy me tea instead, because that doesn't usually make me shaky. So I have to have sugar in coffee. There we go. Fix that solder bridge with my desoldering tool. There we go. It's obviously done with that shorting out, it won't work. You have to give it a bit of a brush down so it looks like it's got bits on it. Oh, that's just bridge, that's annoying. I'll come back to that. Yep. Fix that. There we go. Sure that was even on shot. Oh, it is. It's just down here. So 4 out of the 5 7-segment displays are now in the board. That one at the top there looks like it started to pop up a bit, so I'm going to see if I can figure out I'm going to get that to go back flush. That's fine, can't get that one to go back flush. It's alright, should still work, it's still soldered in. Because it's a double-sided board. Right, so I'm going to show you the construction of one of these 7-segment displays. So, look in the back, see it's all potted with resin. There's LEDs inside there, there'll be surface mount probably. And they put this piece of plastic over the top, which just peels off, and all that's there is to stop the resin dripping out. That's all that's for. But a lot of the time these displays go into products, and I'm not sure what colour these are. I've not actually tested them to find out, but that doesn't matter. Just trying to get this through the holes. I think I've got a bent pin again. Yeah, I might have. Because I stuck it in the polystyrene, so I think some of the pins are bent. There we go. So that's them all in now. Just got to solder that last one, and then we'll put the IC in, and then we'll connect it to 9 volts and see what happens. So the IC is on a socket rather than, but unfortunately because I don't know what programming's in that IC, because it is a PIC microcontroller, I'd have to do some guesswork. kind of ambidextrous when it comes to soldering as well, because I think I've been holding the iron with the other hand. We'll get those leads snipped down once I've started finishing it off. Hopefully this thing will work. Doesn't it? Doesn't. It's a learning curve. Is that just... yeah, it's a bit annoying. It's decided it doesn't want to go into the joint, even though I'm putting it in. A bit of a pull out to try to put my hand on the soldering iron. That would not end well. I'd rather not end up in A&E again. Give that a bit of a helping hand, I suppose. It's got something to go against. I'm not a professional at soldering, not an expert at it, but I know how to do it. Right, so that's now all soldered together, which is excellent news. The solder bridge there, which I'm going to have to clean up, so this is what I'm checking for, just to make sure that everything looks as though it's okay and it's not going. Because that's the problem when I've got to solder a lot of those. If it was one big display that was either multiplexed or something, then that wouldn't be much an issue, but there's far too much solder there, look. Yeah. It's not helpful if I... yeah, now it's just bridged them. Let's try and fix that. There, lovely. Now that should be okay. Let's have a look. Looks fine. All I've got to do is put the microcontroller in and power it up. So the microcontroller is this one here. Shouldn't really hold that one. How about that? It is a pick. Now check all the pins are straight on that because one of them was bent. Yeah, it's that one there. I was trying to bend it too much, otherwise I'll end up with the pin snapping off, and that's not ideal. See if I can get it into the socket. Correct way round. That'll be a good start. So I prefer sockets for ICs rather than... rather than... so we can get that kind of lined up. Sure the pins are lined up and it goes into the socket properly. The reason why I prefer sockets is so that if the IC does actually fail, you can just pull it out and put a new one in. Sure it's lined up properly first. Don't have one of those tools that you use to just squeeze the pins in to make this a bit easier, so make sure all the pins are lined up with the socket. They look like they are, apart from that first one there at the start, which I'm a bit concerned about because it seems to have bent over. Let's see if I can bend it back. Let's see. Now I'm struggling to get this in. This doesn't seem to want to sit in. Now I'm off camera with this. This is a socket that doesn't have a lever on it or anything. You've just got to line the pins up and hope that they go in. Not my favourite type of IC socket. I prefer the ones with the turned pins on them. Right, are we lined up properly? We look like we might be, but I don't want to press this down if we're not, because then it'll flatten all the pins and I'll ruin the thing. This is why I don't like doing this very much. I don't like soldering them in either, because if you do that you can't get them out. I think we might be okay, I think we might be good. We are good. Microcontroller is in the socket. So that's now done. All I've got to do now is find a source of 9 volts and we'll test this out and see if it works. Well, there is a little set of header pins I can put on that as well, which I believe are in the main bag. So I might actually stick them in. Not sure where they go. That's them there. There's 3 out of 4 pins there. So it looks like it's snipped off to 3, but I'm not sure where these go. Now that hole's blocked, so I'm not sure if that was for anything important. That might be for these, actually. Yeah, that looks like that fits there. Oops. So let's give this a test then, shall we? I mean, I don't need to put this header in, but it might help if I do, so I'm just going to pop that down a minute. I've just left my soldering iron in the worst possible place. I'm sure you'd have noticed that. You'd probably be like, oh my god, you've left your soldering iron lying on the ground. Or lying on the bench. Yeah, no. Stuff happens. There we go. That's cleared that, so I can put that turned pin header in there, because I think that's supposed to go in there. Like that. Not sure. There's another position here for a header, which is labelled. I have to take that. Which is labelled minus plus in and ground. Not sure what that's for. Might be for. Let's grab a piece of tape just to hold that on. Let's get rid of that. Put that across like that. That should hold it, hopefully. Let's make this the last bit I solder on, because I'm pretty sure that's where that goes. I don't know what it's for. Might be a socket for testing crystals. Can just poke it through a little. Ow, 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 ow. We're good. Might going to be too much solder on that, but that's fine. I think that's probably what that's for. It's for testing crystals. Bridging it. And the bridge ain't going away. So, it's just slightly off shot, I think. There we go. So I think that's what that socket's for. Now I've got tape stuck to it. I think that's for putting crystals in to test them. So there we go. One completed frequency counter. Could stop the video while I go find... Ooh, ow. Try not to drop it. Some power. Just be back soon. Okay, so what I've done is I've patched across a PP3 battery clip because I couldn't actually find any other 9 volt source. Because you could probably saw that. I've actually pinched the battery out of the... Well, that battery expired in 2018. I'm surprised it still works. Never mind. So I pinched the battery out of the multimeter that I was using. And I'm going to put it onto this and we're going to see if it works. So let's hopefully... Okay. Oh, it's got some menu options. So it's working. That's good. So add, addition, subtract, 0. I'm not sure what that is. Quit. Let's get you out of the menu. There we go. So it is working. I have a 0 on the display. Bring something in that will generate a frequency. Ooh. I'm trying to see if my spectrum analyzer is there, because that can generate on most carrier frequencies. This is a tiny SA, for those that are wondering. I was supposed to do a video on this. I don't think I've done it. And, right, so mode, Switch to low output. Frequency is at 10 megs. Let's turn that on. Wave it roughly in the direction of that. Oh, that's not modulating, probably doesn't help. And now FM. Okay, it's got modulation. Let's see. Sure, that was. Just trying to figure out how to work this thing. Okay, so that's generating a carrier at the moment on about 10 megs. So, should have showed that. So I'm just going to have a look. So I've got 0. I'm not sure what that is. Can't be table because that would be an E, isn't it? Quit. I think I've got a segment out on this display. This was testing crystals. 10.7, 455, 300. That's what this was. Crystal test. But I think I do actually have a segment out on the end display, but otherwise it works. I'll have to have a look at that, find out why that's not working. Oh, if I do that, it makes things go weird. Probably. Yeah, this would be table or crystal test. Don't know. Quit. Okay. So I'm not sure what this is meant to do. Go for program. What's program do? I'm trying to work out what does what. I think I might have some segments out, I don't know. Right, that's interesting. Just going to move the camera into a better position so I can see this. So here's the finished article. I think I've got a segment out on one or two of the displays, the way it's working. So this is just some menu options that are in it. We go into this one, which I'm guessing is table, like different crystals, including the 10.7, and there's definitely a segment out on that end display, so might need to have a look and find out why that's happened. But it's worth a look. It's built, it's powered up, it's doing things. It's not reading anything off the Tiny SA, even when I put the thing anywhere near it. Finding a bit bizarre. Let's see. It looks like that socket is for putting crystals in. I don't have any crystals lying around testing it though. So, you know. Anyway, there's a little project. Seems to do what I expected it to do. It powers up and switches on, which is what I wanted it to do in the first place. Yeah. I think that's probably just a reset. Don't know. Let's bring this in, because this is generating a small RF field. It's not actually registering that, which is interesting. And I thought it might, but it isn't. Not sure what this one is. Oh, saying 16.671. I'm not sure what that was. It's just switched itself up, right? It's flashing that 0, which is interesting. So it does work. Powers up. Doesn't really work as a proper frequency counter like I thought it might, but it was a kit. It was well worth putting together. So, you know, I'm pleased that it works. That's the main thing. So, Paul, Mike 0, Whiskey November uniform, 426 Charlie Tango 730. If you catch me on 11 metres and PMR 446, or just a red squirrel on the old CB. Now, like I say, I'm not an expert at building kits, but this one was worth a go and certainly seems to be okay. So I'm going to take the battery off it now, and, you know, it's nice to have a go at building kits now and again. I don't do construction much on this channel, and if you have managed to stick through this whole video, I applaud you, because it's probably going to be one of my more boring videos, if you think about it, if I'm being brutally honest, but, no, you might find it entertaining, I don't know. So, well, yeah. So, yeah, I was a bit shaky with the soldering earlier, which might be part of the problem, but, you know, I'll have a look at my soldering on that later on. And, yeah. So, I'll catch you in the next video, and if you like, you can buy me a coffee as well, because I do actually have a buy me a coffee page. That's if you want to, of course, you don't have to do that. So, I'll catch you in the next video. It won't be as long as this, and it shouldn't be as tedious either. Hopefully the next video will be comparing the PNI Escort HP 7120 and the Thunderpole T600. Because there are some noticeable differences. I've already had a sneak peek myself. So, I'll catch you in the next video.